In this video, we will use a camera mapping technique to project parts of a 2D image on 3D objects. We can then create a camera animation and get the impression that we are moving through the 2D image. First, let's take a look at the original image we are using. The image was then slightly modified for the purpose of this demonstration. Now we can load this image in rotoscope in the camera view in the B viewport. We now need to give the camera a field of view angle that matches the photographer's camera angle. We also need a rough idea of the height of the camera and its orientation. Since we don't have that information, we'll use a trial by error method. Let's get a cube to create the left wall and then move, pan, and zoom the camera until the cube's perspective matches the wall's perspective. You can also scale, rotate, and translate the cube to give it the shape of the object and position it. Try not to translate in Y, or if you do, make sure all your object's base start on the same plane. You need to play around like this until you match the perspective. If the perspective angle of the cube is too high, basically a wide angle, you can zoom in and dolly out in increments. If it's too small, zoom out and dolly in. Then you orbit, pan, translate, rotate your object, and eventually you'll find a match. From there, you can select the points of the cube and move them around. Or the side polygon of the cube and duplicate it to build the object you're trying to match in the image. It doesn't have to match perfectly because this process is very forgiving. So let's just leave it as it is. Now let's get another cube for the building on the right. We'll move it around from the top view. Then we'll scale it, move it some more, and move some of its points to fit the building. The other objects were created and positioned to measure their corresponding element of the 2D image. For each of these objects, an image was created from the original where the relevant pixel details were isolated. This image, for example, will be mapped on a church tower. It was created with an alpha channel. Now let's take a look at the rest of the images we're going to use. So far, the camera angle, position, and orientation have been approximatized, the objects created and positioned, and the images prepared. Now we'll get a texture for each object. After applying a Lambert, we'll get an image shader and a picker shader in the render tree. We'll connect the image to the Lambert's ambient and diffuse port, and use the alpha channel to drive the transparency and basically discard the unwanted portion of the image. From the image shader's property editor, we'll get the texture. Now is the time when we specify that we want to use the camera's point of view to map the texture on the object. Now let's draw a render region and see the first result. All the objects have now been textured with the same camera mapping, each with their respective images exactly as we did for the church tower. The background grid, however, is using a gradient shader. Its colors were set from samples taken from the image itself. Let's take a look at the final result. We can now animate a camera to move through our scene. We'll use another camera, a duplicate of the current one. We'll save two keyframes for the camera, one at frame 1 and the other at frame 30. The amount of movement is limited by the texture information that we see on the image. Obviously, we can't go around the building. But this technique can be a real time and money saver on certain productions. The images were rendered. We can now use the flipbook to view the result.